Welcome to MCL, Maths with Conceptual Learning. Today we will learn about properties of functions. So in our last lesson we learned about functions. So what are the properties of functions? We will discuss about one-to-one, onto functions, bijection, composition, and inverse functions. In this video, we will learn about one-to-one functions. A function f a to b is said to be one-to-one or injective if f of x is equals to f of y. This implies x is equals to y for all x and y in the domain of f. A function is an injection if it is one-to-one. Intuitively, an injection means that each element in A uniquely maps to an element in B.
Here comes an example. F of x equals 5x plus 9. So the mapping for this function can be seen as each input value maps to one output value like this. So by the definition of one-to-one function, in this mapping, each input value maps uniquely to only one output value, as -4 maps to -11, -1 maps to 4, and so on. So this function is one-to-one. We have another function, f of x equals x cubed plus x squared, -4x, -4. So as you can see, -2 and -1 maps to the same output value 0. So this function is not one-to-one since two input values maps to the same output value 0, which contradicts our definition of one-to-one function. Here comes a detailed example. We have given a function where the domain and range be the set of real numbers defined by f of x equals 2x -3. Now we have to find that this function is one-to-one or not. We consider for f of x equals f of y, and we have to find x equals y. So 2x -3 equals 2y -3. By applying cancellations and operations of addition and subtraction, we get to the result that x equals y. This satisfies our definition of one-to-one function. So this function is one-to-one. Here comes an exercise. In the first question, we have to find either this function is one-to-one or not, and the domain and range is given by the set of integers. And in the second question, we have to find another one-to-one function for another function, f of x equals x squared -5x plus 5, and the domain and range be the set of real numbers. By recalling to the previous examples and previous definition of one-to-one, I'm sure you can do this.